Yeah, please go through the problem statement. What the problem statement is all about, what it is saying. Aman, you can read this out.
Okay, sir. Video documentaries of various ISRO missions and programs are available. To categorize all video programs, generation and verification of huge amount of metadata generation needs to be done. With current deep learning methods, based development in field of computer vision and natural language processing, this task of video metadata generation is nowadays automated. Given video programs, process for objects, text, speech recognition, named entity recognition, etc. To classify the videos in different genres like launch programs, interviews, educational programs, outdoor shots, public shots, traffic, etc.
Yeah, this was a description of a problem statement. Do you see any problem in it, or is it talking about an idea, or is it talking about a solution to a problem? The first thing is you need to understand the problem statement. If you don't understand a problem statement, you won't be able to chart out an idea for a solution of a problem, right? So the first question, like this screen is visible to everyone, I suppose. Okay, everyone is able to read this description. I want all of you to go through this documentation of a description, okay, one time, two time, or three time, and tell me what problem it is talking about. Do you see a problem? Do you see
So
this statement
categorization.
unambiguous? Do you see this statement clear? Is this a clear statement? If it is not clear to you, what are the points which are making it unclear? Yes, Aman, you were saying something when I was saying something.
So I think the problem is clear to me that they need some kind of categorization
Okay,
for
they need
their
some
video
kind of
metadata.
okay, so they are saying that video documentation of various ISRO missions and programs are available. So they have some data, right? They have some video documentation regarding various ISRO missions and programs. What they want to do, they want to categorize them. That this kind of data pertains to this event, that kind of data pertains to that event. Okay, they want to categorize the data, right? Is this your understanding, Aman?
Yes, sir.
Okay. What other than categorization that they want, or is it the only thing which is categorization which is required? Are they also asking for other things other than categorization? Aman,
Thinking, sir.
yeah.
They uh, they also need their data to be further bifurcated into different categories like launch programs, interviews, educational programs.
That is also called categorization, right? That is no different than categorization.
Yes, yes,
Okay, so we can say that they only want a categorization, isn't it?
yes, sir. In my understanding.
Okay, yeah. This is the categorization. Okay, fine. So it says that it also tells you that to categorize this kind of data, you need to generate and verify. Okay, so there is a term called generation and verification. To categorize the all video programs, generation and verification of huge amount of metadata generation. Now, do you agree? Do you understand what is the meaning of metadata? One thing is called data, other thing is called metadata. What is the difference in a data and a metadata?
Not sure, sir.
Okay, metadata is information about the data. Let's say if I say that this class is going online. Okay, this class is being held online. So what will be the metadata of this class? Metadata of this class is the time at what this class has happened and the topic which is being discussed in the class. Okay. So data about the data is called metadata. Okay. Data, let's say, for example, if you have a video, okay, after this lecture is being recorded, after this class gets over, okay, so I need to label that video with some name. Okay, so what I would do, I can also choose a topic which is discussed as a name of the video. Okay, I can also specify the name of a presenter, like I am talking to Aman Singh, other people are just listening, some people are traveling, okay, but I'm interacting with Aman Singh. So I can also say that session with Aman Singh. Okay, so that session with Aman Singh statement can be treated as a metadata. Other metadata can be the mode of a lecture, it was online. Okay, the other metadata can be the length of a lecture. Let's say it's a 1 hour lecture, so time, okay, time or duration of the lecture is also a metadata. So a data which is pertaining to the existing data, which is telling you some attributes of the existing data, is called metadata. Is it okay? Is it clear, Aman Singh, or is it clear, everybody?
Yes, sir.
What is metadata? So it says that if you want to categorize all video programs, you need to generate and verify huge amount of metadata. Okay, and generation and verification of huge amount of metadata generation need to be done. Okay, in order to categorize data, you need to categorize metadata also. Okay, so one of the solution that they have already discussed in the problem statement, one of the solution that they have mentioned a technique name. That technique name is called deep learning. Okay, how many of you are comfortable with this term deep learning? Have you ever heard of this term deep learning, or this is the first time that you're hearing about it?
So have heard of it, but never really got the hang of what it really is.
Okay, you have already heard about it. What about other people? I mean, if I talk to Ved Prakash, Abhishek Gupta, and Gargi Sharma, Ishita Chan, Diya Bhattacharya, and there are other
Heard of it,
students
sir,
also.
but don't know what it means.
Yeah, what are you saying?
Sir, I'm saying that I've heard of it, but I don't really know what it means or what
Okay, you
its
don't
purpose
really know
is.
what it is.
No,
Okay,
sir.
okay, fine. I'm writing it on to the chat window about the deep learning method. Deep learning. What deep learning is? Deep learning is a kind of machine learning. So, okay, machine learning. Have you ever heard of this term, machine learning, or this is the first time that you're hearing it, or you have heard of it, but you do not actually know what a machine learning is?
So machine learning I've heard and I know.
You have heard of it, and you have some idea what it is.
Yes.
Okay, what idea do you have? You can also use this chat window so that other people can see. You can use the chat window to type your answer, or if you want to communicate verbally also, you can also say verbally. What is machine learning?
So the basic idea that I have is that it allows softwares to become more accurate at predicting outcomes without actually being programmed to be done so, like self-evolving at the same time.
Yeah, okay, other people, have you understood what Aman is talking about? Do you want me to explain this machine learning a bit more detail, so that we can get to know about deep learning in a bit more detail, so that at the end we can get to know about a problem statement which is being discussed in more detail? Do you want a session on a machine learning this class? Let us just convert, I mean, this is just my idea, that because one of you might be knowing this machine learning, but most of you might not be knowing this machine learning. Some of you might have heard about deep learning, but all of you, as I figured it out, that you do not know what a deep learning is all about. Deep learning is a kind of a machine learning. Do you want me to explain this machine learning to you people, so that you can understand the problem statement better? Okay. So what I'm doing is I am stopping this share for a while so that I can come up with a new presentation which is all about machine learning. Okay. So what I'm doing is I'm stopping this share. Okay, let me just stop this share. Yeah, Abhishek, you have, this is your screen. You have to stop a share. Not Abhishek, Aman. I think Aman. Aman, you are sharing it, right? Yes, yes. Okay.
Done, sir.
Yeah. Just hold on. I'm just connecting my presentation so that you can see to it. Give me few moments. Okay, I am going to share my screen. So before going to study about machine learning, you need to understand the concept of a neural nets. Okay. So let's talk about neural nets so that we can figure out what a machine learning is, and then we can figure out what a deep learning is. Do let me know if the screen is visible to you.
It is visible, sir.
Okay, it is visible. Fine. Good. So we will be learning this neural network through a story. Okay, and I'll talk about a story later, but first of all, let me just tell you what a neural network is. Okay, so it's an idea. Okay, it's an idea that has been taken from mathematics and computer science. Mathematics is treated as a backbone of a computer science, and you must have heard of this term called artificial intelligence. Like these day
Yes, sir.
devices are artificially intelligently enabled. Yesterday I went to Vijay Sales to buy an AC for my room, and most of the ACs were like AI enabled. Okay, mobile devices are AI enabled. This kind of thing, which is called neural network, okay, it has taken this artificial intelligence world by storm. The way you ask a question from your phone, okay, Alexa, you say, hey Alexa, do this for me. Alexa will do that for you. Okay, Google, do this for you. Do this for me. Google will comply and do the job for you. The way you show a pic to your computer and ask which animal it is, or ask it to describe the scene in a picture, all such kind of a stuff is being driven by neural network. Okay, so I hope you people can figure out a sense what is written in this slide. Should I go on to the next slide, or do you have any question? Is there anything that you want to get understanding? I mean, you want to get understanding of this slide? Should I safely proceed to the next slide?
Yes, sir.
Okay. Okay. Fine. So the objective of this thing is we'll be taking some ideas of linear algebra and calculus. I hope you people are comfortable with some basic concepts of mathematics, linear algebra and calculus. You must have done it in 10+1, 10+2. So, or 10th class also, you must have done some linear algebra. I mean, if I ask you to find out an equation of a line, if you have a line in x-axis and a y-axis, if I ask you to find out an equation of a line, it's y is equal to mx plus c. Do you remember, or you forgot all those things, how to find out an equation of a line?
No, sir. Remember.
Students, do you know linear algebra? Do you know calculus?
Yes, sir.
Okay. So then we'll be able to write our neural network using Python. Okay, so we'll be making use of Python. Not immediately, but first of all, we'll be moving gradually. I don't want you to immediately jump onto a programming language like Python because this is totally computer science stuff. Okay, before jumping onto the computer science stuff, I want you to get comfortable with the terminologies which are involved. Okay, so let's understand. Let's understand what neural networks led computer to today. Okay, some of the thing I have already shown you, the way you ask a question from your phone, the way you show a pic to your computer and ask which animal it is, or ask to describe the scene in a picture. Okay, let's understand how what neural network led computers to today. See, computers are better at seeing things. In 2015, computers outperformed the humans in recognizing patterns. Okay. And they are also good in hearing us. Okay. Yes, Pradeep, are you there? Pradeep Dixit. Hello, Pradeep Dixit. Pradeep Dixit, I want to talk to you.
Yes, sir.
Pradeep, please get yourself in a particular section where there is no surrounding noise. I don't want you to get disturbed by the noises which are surrounding.
Okay, sir. Okay.
Okay. And it will be really nice if you all turn your cameras on so that I can see you where you are. What are you doing? Aman Singh, Ved Prakash, Abhishek Gupta, Gargi Sharma, Ishita Jain, and Archita Arath, Hiya Bhattacharya, and other people who are there. I want all of you to turn your cameras on so that I can see you where you are and what are you doing. Yes. Okay. Other people who are not listening, are they are in the meeting or not? Okay. Ishita and Abhishek. Okay, Abhishek has raised a thumb but not ready for the camera. Okay. Ishita, what about you?
So your voice was great.
Ishita, are you able to hear me? I think Ishita is not able to hear me. Okay, anyway, majority is able to hear me. So guess, okay, let me just continue with the presentation. Okay, guess what they can respond, what they can respond to as well. Okay, so if you ask some question from Alexa, Alexa can also talk to you back. Okay, similarly, Google can also talk to you back. Google Assistant can also talk to you back. Okay, first we'll take an example problem and we'll try solving it manually. Okay, and then we will be seeing how we can make a computer learn solving it using something called backpropagation. Okay, so the technique, like as the name of a subject is problem solving with technology. So first of all, we'll be solving a problem manually, and then we'll be using a technology. And that technology we are going to use is backpropagation. Okay. So this is the base of an introduction of machine learning with neural networks. So let's start with a story. There is a story of a farmer girl. Okay, so there was a girl, okay, farmer girl. She likes to measure everything around her. She was growing some flowers and realized that she hasn't measured them. Okay, so she decided to measure them today. Okay, so she had the two categories of flowers. One is a blue flower, other is a red flower. Okay, so red flower and a blue flower. So she wanted to measure their petals, and she had a measuring scale, and on which she was about to measure the width and the height of a petal. She took a petal out of a red flower and saw that, okay, this is 3 feet, 3 inches wide or 3 centimeters wide. Unit is not a concern over here. It's like 3 unit wide. Okay. And some unit height, let's say 1.5 unit height. So she recorded it. She recorded the dimensions. Okay. Like 3 was a length and 1.5 was a width. Okay. And the color was red. And she took the same thing, took the same similar kind of a measurement for the blue petal also. Like length was 2. Okay, and she did it for a number of petals, you know. Okay, so this is how there were multiple of them, and she decided to measure many of them. Okay, are you getting me what I'm talking about, students?
Yes, sir.
Okay, so but wait, while she was recording, she missed something. Okay, did she miss something? Yes, she missed recording the color of one particular measurement. Okay, so you see this last measurement. She recorded that length of the petal was 4.5 and width was 1, but she forgot to record the color of a petal. Okay. She started thinking how to solve the problem. Now this is a problem. Now she started thinking how to solve a problem. Okay. And she got a better idea. Okay. And you can see the smile on her face. She got a better idea. And what was the idea? She regraphed the data. Okay. She took, let's say, the first petal dimension was red petal dimension was 3 and 1.5. She regraphed it. She plotted the red over there at 3 and 1.5 on a scale, and she regraphed the entire data. Okay, whatever colored information she had 1, 2, 3, 4, 5, 6, 7, 8. She had a data of 8 petals. The 9th petal information was missing. Okay, then she also plotted the question mark. Okay, the question mark was 4.5 and 1, 4.5 and 1. This was a question mark. And she made a guess. Guess was like, this question mark is surrounded by red petals. So probably she's thinking that this could be a red petal. Okay, so this is like categorizing. So now she's thinking that, okay, fine, because the question mark is surrounded by lots of red petals. Okay, so this could be red. This could be equal to red. You got my point, students?
Yes, sir.
And she made a good guess. Now her data set looks complete. Okay, now what she did, she turned that question mark into red petal. She wanted to teach it to computer because see, she also has to farm in the field. Okay, and she's not free to measure it all the times. She wanted to teach it to computer. Hey computer, okay, if in any case you miss a particular measurement, okay, how to figure out the result. Okay, so the brain of a computer is considered as a neural network. Okay, and when it is said that she has to teach it to computer, she has to teach the technology or a technique to a computer. Okay, so we are going to discuss how to teach it through a neural network. Okay, farmer girl on one side, neural network on the other side. What is a neural network here? Neural network, for the time being, just consider it as a brain of a computer. We will actually talk about what actually neural network is, okay, when we progress through this session. Okay, so on one side you have a farmer girl, on the other side you have a neural network. Okay, so let's train a computer brain. What is neural network? It's a computer brain. Just consider it as a computer brain. Okay, so the same kind of a data where there's a question mark. Okay, question mark for one particular measurement, like farmer girl missed that particular measurement. Okay, so what is required? Let's say these two circles which are at the bottom, put in one length and put in other the width. Okay, let's say here, if we talk about the second, just look at the second measurement here. Are you able to see my cursor? I'm moving my cursor. Second dimension.
Yes, sir.
Okay, so 2 will be written. Okay, okay, fine. So 2 will be written in one box, let's say, and 1 will be written in the other, not box, but a circle. Okay, and the other circle. So we are going to process this 2 and 1 to generate something for this circle. Okay, so let's say I'll tell you why this 0.8 has come. So we are going to process this 1 and 2 in such a way that you are going to get a value from 0 to 1. Okay, and this being a probability. Okay, 0 to 1 a probability. 0 probability of color being red, 1 probability of color being blue. Okay, 0.8 means 80% probability of a color being blue. Okay, so let's say you have processed this 2 and 1 in such a way that you have come across a number which is 0.8. Okay, so that 0.8 is some number which is on the scale of 0 to 1. And let's say farmer girl had decided beforehand, she has decided that I'm going to process this length and a width, okay, to get some number. And if the number is near to 1, then it is probably a red color. If a number is near to 0, then it is a blue color. Okay, but here it's clear that 2 and 1 are processed. Answer is 0.8. 0.8 is near to 1. Actual color of a petal is blue. Okay, but the calculation resulted it in 0.8. That means calculation is something wrong. What this calculation is all about? Calculation is the understanding of a computer. Computer has understood it to be of a red color, but actually it is of a blue color. It is like training a person who is naive. Okay, it's like training your dog. Okay, or training your pet animal. Okay, how do you train your pet animal? How do you train your dog? You give incentives. Okay, if a dog or a pet animal has done a good thing, or punish if a dog or a pet animal has not done a good thing. So from a reward, okay, dog or a pet animal will get to learn that this is something good. She enjoyed it enjoyed the reward, and she must, or it must, keep on doing it for a longer period of time, so that it enjoys the reward in future also. Okay, so initially it can make mistake. Like initially when you teach a computer also, okay, it can make mistake. Like in this case, you can say that it has made a mistake. It has come out with 0.8, which corresponds to red, but actually the color is blue. Okay, so how, now let's talk about how this 0.8 has come. Okay, we were talking about training a computer, and now we are talking about something called function. Function is something that can take some numbers, can process that number, and can generate a new number. Okay, like in this case, in this particular case, okay, when you gave a computer 2, which was the length of a petal, 1, which was the width of a petal, okay, computer has processed it. Computer has done some functionality onto these numbers, done some processing onto these numbers, and the result was 0.8. Okay, so function, what is a function? Function is a relationship. For any particular number, okay, you have the number in the other domain. So let's talk about these two circles. In one side, there are 1, 2, 3. On the other side, there are 2, 4, 6. Okay, so if you say that, what can you do to this 1 to make it 2? You can multiply that 2 by 2, right? 1 multiplied by 2, you to get to 2. What can you do to this 2 to make it 4? Multiply by 2, multiply by 2, so that it gets to 4. What you can do to make this 3, 6? Multiply by 2, so that you can get 6. So what is the relationship? Relationship is here multiplication by 2. Okay, so this circle is called domain of numbers. This circle is called range of numbers. So whenever we discuss about relationship, we have a domain of numbers, we have a range of numbers. Domain of numbers are the inputs to the functions. Range of number is the output of a function. Okay, so I'm just telling you what a function is. Function is a relationship. Okay, and in our case, like here, when we were discussing this neural network, okay, this circle and this circle are capturing measurements. So let's say this is measurement 1, this is measurement 2. Okay, length and width are the measurements. So in general, we can say something like this, like neural network looks like this, 3 circles, okay, connected in this way. One circle captures measurement 1, other circle captures measurement 2. So let's name the inputs. M1 is the name of a measurement 1, M2 is the name of a measurement 2. Okay, and then what we are going to do, we are going to assign weights to the edges. Okay, so we are going to, so these are the edges. This is an edge and this is it. There are 2 edges over here. So we're going to assign weights to the edges. So this weights will represent how much important this measurement is. Okay, how much important this measurement is. So you can assign W1 as a weight here, W2 as a weight with another edge. Okay, like this. Okay, W1 is given to one edge, W2 is given to other edge. Okay, so then what we are going to do, we are going to take this M1 out of this circle, multiply that M1 with W1. Okay, and then M2 out of this circle, multiply this M2 by W2, to make it something like this. Okay, so this edge is taking that M1 out, multiply that with weight of the edge. Okay, M2 out of the circle, multiply that with weight of 2. Okay, weight of the second edge. And at the top, it does what? It adds both the terms. And it also adds some bias term. Add them at the output stage and add some bias to it. Whatever calculation you are going to do will decide the number for this particular circle. And then what do you need to do? You need to pass this whole calculation to some function called sigmoid. Okay, see, when you are multiplying numbers together, when you are adding some numbers together, you are not supposed to get number between the range of 0 and 1. Okay, you may get 6, you may get 16, you may get 65, 66, something like that. But in order to be sure that you want a number in the range of 0 to 1, so there is this kind of a gentleman, which is called sigmoid. Sigmoid will convert every number which is passed to it in the range of 0 and 1. Okay. Okay, fine. See here. Let's just talk about here. In this case, I was talking about like this was a measurement 1, this was a measurement 2, and answer is 0.8. Okay. So 0.8 is in between this range 0 and 1. So which function is responsible for getting you an output not less than 0, not more than 1, but between 0 and 1 is called sigmoid method. Okay, so let me just go through the process one more time. So measurements are given to 2 nodes. So these circles are called nodes. Node number 1, node number 2, and node number 3. Here, this node is called the input node 1. This is input node 2, and this is the output node. Okay. Or you can also say that this is a neuron. Neural network has some called neurons. This is neuron 1, this is neuron 2, okay, and this is neuron 3. Okay, neuron 1 passes an information to neuron 3, and that information is not directly passed to it. It has to be multiplied by the weight of the edge. Similarly, M2 information also is not directly passed through this particular neuron. It has to be multiplied by the weight of the edge. Okay, so to treat it like that. Treat it like that. Suppose we see some particular event happening, right? And if we find that event interesting, then we tend to remember that thing. Okay, if that event is interesting, that means we have associated more weight to that event. So that interestingness, finding a particular event interestingness is equal to attaching more weight to it. Okay, if you do not find an event interesting, you are not interested at all for a particular subject or for a particular event which is happening, you associate a 0 weight to it. So it doesn't matter how lengthy an event is, if you are not interested, you are not going to remember it. Okay, similarly for this particular lecture, if you are not getting interested for this particular lecture, what is being happening in this class, okay, you would assign 0 weight to it. So 0 will be multiplied by whatever is happening and will result in 0. Okay, do you agree with this or not? We tend to remember things if things are interesting. Okay, if they matter to us. If they do not matter to us, if they are not interesting, something is happening in some part of the world we are not bothered about. So we can say that, okay, fine, we have associated very less weight to it. Okay, and when we associate very less weight to it, we tend to forget it. Okay, so we tend to remember things when we associate weight to those things. So these edges, okay, these edges represent weights. Understood? And as a human being, are you still connected, students? I mean, I'm seeing 10 students associated. Let me just have a feedback call. Abhishek, Aman, Archita, Gargi, Harsh, Hiya Bhattacharya, Ishita, Kirti, Pradeep, Prakash. Are you connected and are you listening?
Yes, sir.
Are you
Yes, sir.
getting?
Yes, sir.
Yes,
Are you
sir.
understanding it?
Yes, sir.
Okay, if you're understanding it, then it is good. If you're not understanding it, then increase that weight. Okay, it's all about weight. Increase the weight so that you can understand it. If you want me to increase the weight, Okay, I can also help you in that case. So is there anyone in this class who is not getting what I'm talking about? Ved Prakash, are you getting it? Pradeep Dikshit, are you getting it? Kirti, are you getting it? Ishita, Hia.
Yes, sir. Yes.
Okay, okay. Okay, fine. I can safely assume that yes, you're getting it. Okay, so it's not about multiplying. It's not only about multiplying the weights with the measurements. You also have to associate it with the bias. Okay, so this bias term. Okay, so what is this bias now? Bias is like inclination toward one particular team. Okay, so biasness is required to avoid 100% perfection. Okay, so we don't want to be 100% perfect. Okay, in fact, human being, we generally say that human being is not 100% perfect. Every human being has errors. Okay, and we also want to make a similar kind of a learning to a computer. We don't want a computer to be perfect. We also want a computer. Like when we talk about machine learning, when we talk about robotics, when we talk about bots acting like a human, we don't want bots to be 100% perfect. We want bots to be biased like human beings are biased. Okay, so we say that human beings are biased. They prefer one particular category over the other category due to its own prejudices or biases. Okay, and that's the reason we also add biases over here. Okay, so we'll be talking about what a bias is in this particular case later when we proceed with this course. So sigmoid is a function which is responsible for getting your answer in the range of 0 and 1 only. If you don't do a sigmoid, you won't get a value in the range of 0 and 1 only. So this is the formula for a sigmoid. Those with a mathematical background can figure it out. What is this? 1 divided by 1 plus exponent raised to power minus x. Okay, x is the number that is passed to it. Now, if you take a number -5, let's say -5 is x. Okay, so if you calculate it, it will be 0.0067. Okay, so this is very much in the range of 0 to 1, and it is near to 0. Okay. So if you draw a graph of a sigmoid, this is how it is drawn. Okay, it doesn't go. So this line is 0 line. This line is 1 line. It never crosses 1. It never crosses uh, negative to the 0. Okay, never goes down the 0. It never goes up 1. So this is the line. Okay, that we are going to get. So the formula, if I ask you to write a formula for it, like a function for it, so you can say that NN is a function, neural network is a function that takes two measurements, measurement 1 and measurement 2. Okay, and it calls a sigmoid method. And inside a sigmoid method, what is happening? There is some weight 1 of an edge, multiply that with first measurement. There is some weight W2 of another edge. Okay, multiply that another measurement with that and add a bias term and give it to sigmoid. Whatever answer you are going to get, it is for sure will be within the range of 0 to 1. Okay, and that will be the output of a neural network. Okay, for example, if measurement 1 is 2 and measurement 2 is 1 for the second battle. Okay, so W1 will be multiplied by 2, W2 will be multiplied by 1, and there will be a bias term. Now, what will be this W1? What will be this W2? What will be this B? Initially, they'll be random. They'll be random numbers, because when we are supposed to train a machine, okay, machine learning, when we're making machine learn, initially we do not expect it to complete the prerequisite of something. Like this course. Let's talk about this course. Okay, this course is problem solving with technology. This is a core course with an engineering category, and I do not assume any prerequisite for this course. Okay, the state of your mind, I am expecting purely random. Okay, so randomness will be organized as the course progresses. Okay, randomization will be converted into organization. Okay, properly organized as the course progresses. But just because I do not assume any prerequisite of this course, okay, so that it can be digested by student of every school, maybe it could be a biosciences, it could be, design, it could be some other school. Okay, so there's no prerequisite, and because there is no prerequisite, the state of mind of few people can be random. Similarly here, W1 can be random, W2 can be random, B can be random. Okay. So let's say if we're talking about random, let's say W1 is 0.5, W2 is 0.2, and bias is 0.3. Okay, and if we do this way, okay, so you calculate it to be 0.5 multiplied by 0.2, okay, and then 0.2 multiplied by 1, and then 0.5 multiplied by 2, not 0.2, 0.5 multiplied by 2, okay, that will be 1, plus 0.2 multiplied by 1, okay, that is again 0.2 only, 0.3. If you add 0.3, it will be 1.5. Okay, 1.1 plus 0.2 plus 0.3 will be 1.5. So if you calculate sigmoid of 1.5, okay, and see it on a graph, okay, sigmoid of 1.5, it will be this. It will be 0.82. Okay, so that is the reason here when we were discussing how this 0.8 came. Okay, because we picked up random value of W1, we picked up random value of W2, we picked up random value of bias, and those random values that we picked up was 0.5 for W1, 0.2 for W2, and 0.3 for bias. We performed that function, we got a number 1.5, and we calculated the sigmoid of it. Okay, and sigmoid of it was 0.82. It was not actually 0.8, it was 0.82, but somehow we ignored that 2 because we were only interested in one precision number after dot. So that's how we got that 0.8 number there. Okay. So 0.8. Now farmer girl mentioned. Now let's turn back our attention to the farmer girl. Farmer girl had a scale. Okay, and she mentioned that if a number is near to 1, it has to be of a red color. If a number is near to 0, it has to be of a blue color. So as per the machine picked up random variables. Machine picked up random variables of W1, W2, and a bias. 0.5, 0.2, and bias is 0.3. Machine has guessed it incorrectly because we know that the petal that we are guessing is of a blue color, but here as per machine it is of a red color. So okay, so it's not a blue, it's red color. Okay, farmer girl is sad. So farmer girl has to punish the computer. Punish in the sense it will tweak its W1, tweak its W2, and tweak its bias. It will say change your randomness. Okay, so that your number gets near to 0. Okay, and she's annoyed with the poor performance. This makes the way for training. So see, there is a question of training. If somebody needs training, if somebody is already trained, then there is no requirement of a training. In this case, computer needs training. Computer needs learning. Okay, this makes the way for training. Show it some examples and make it learn. Okay, it says that, okay, fine, this is a red petal. Okay, get me some number which makes it a red petal. So see, red petal means get me some number that is near to 1. Okay, so she showed some example. This is red petal. Measurement is 3 and 1.5. Do some calculation with 3 and 1.5 so that you can get a number near to 1. Okay, and show it where it made a mistake. Okay, so it made a mistake when it calculated 0.8 as a value. 0.8 is near to 1. It decided it figured out it was of a blue color. Okay, it was of a a red color, but it was of a blue color. Show it where it made a mistake. Okay, now she's showing it where it made a mistake. She was not happy, she was not sad. She was saying that, okay, hey computer, you did a mistake. Computer is sad in this case. Computer realized its mistake. Now for correcting its mistake, it had to change that W1 and W2 and a bias so that it gets some number which is near to 0. Okay, so she then asked it to generate something near to 0, and it changes W2, W1 and W2 and bias and tuning these variables W1, W2 and the bias so that it gets some number which is near to 0. Okay, it's 0.4 she got, and she's perfectly okay with it. Now This farmer girl is no longer sad, and this computer is also no longer sad because computer has learned to generate numbers. Okay. So in the next session, we'll be talking about how to make such adjustments. We talked about how to make adjustment to get the prediction right? Okay, how to do these adjustments. Doing adjustments is called back propagation, right? So I talked about the technique of a back propagation. Problem solving with techniques. So here we'll be talking about techniques of a back propagation. Okay, so here I think here we talked about the technique of back propagation here. Okay, so in next lecture we'll be doing it. This is it for today's session. There's some people who are consistently, coming in the class, going out of the class. I'll share this recording with you people. Okay, and I'll be sharing this recording on Moodle so that whatever piece of information you missed out of this class, you can refer to this lecture later and can always, bridge the gap that might have created due to internet connectivity. Pradeep Dikshit has also entered the room. Okay, I'm stopping this share. I hope those who were consistently connected have understood this lecture, have understood something out of it.
Yes, sir.
Yes, sir.
Okay, fine. So I am okay. Just hold on. Let me just prepare that attendance link so that you can mark your attendance. Yes, Harsh, you have raised your hand. You want to ask something?
Yes, sir. Sir, actually, in the last class, you have given a hackathon to submit our idea.
Yes. So you did not
Yes, sir.
submit
Sir,
idea.
Actually, I have prepared a presentation upon it, and I missed the deadline. So, if you can increase the time
Harsh,
slot,
you're
so
not
I
properly
can.
audible. If you can type your, or you can also WhatsApp me later. You're not audible properly. But
Sir,
I
can
hope I am
come
audible to every one of you, right? Because I have
Sir,
gone
can
through
I
the
come to
entire
your
lecture.
room?
Harsh, you
I
can
am in
write
the
it down
campus.
in the chat window. Okay, meanwhile, Harsh is typing. Let me just prepare that attendance link so that I can share it with you people.